A reliable control mechanism is essential to the smooth operation of any AV system. And in order to tell the receivers which video stream they need to connect to, an SDVoE controller is required. This course will explain how this control takes place and which equipment is used to do it. The foundation of an SDVoE system is the API or Application Programming Interface. Unlike a matrix switch-based system, which relies on a chunky piece of hardware to control the endpoints, SDVoE endpoints take their instructions from software. There's a pretty big clue in the name. Think of matrix switching as hardware-defined video. The buttons on the front of the matrix switch determine which video needs to be sent to which endpoint. Sure, you can use a third-party controller to tell the matrix switch what to do, but all that happens here is the third-party controller is pressing the buttons instead of a person. Whoever or whatever is pressing those buttons, the matrix switch has to be there.
To best explain software-defined video, let's refer to our old friend, the OSI model. If we look up here at layer 7, we can see where the SDVoE API lives. If you need a refresher on what an API actually is, head over to the API course here in Academy. You can find it in the Certified Design Partner suite of courses. This API provides all the control information any SDVoE endpoint needs to do its job. And because it's software-based and common across the SDVoE ecosystem, it can be utilized by any control software from any SDVoE vendor.
When a vendor manufactures SDVoE endpoints, we at SDVoE provide them with a software API, which they then incorporate into their own software. Usually, the vendor will build a small controller which drives their software with SDVoE API included. But as far as we're concerned, it doesn't need to live on any particular physical device. Providing the software which is developed by the vendor is able to incorporate the SDVoE API, then the endpoints will be controlled. Remember, SDVoE provide the API which the vendor must use, but it's the vendor's responsibility to create the software which is used to control the system.
The SDVoE API is the beating heart of an SDVoE system because it guarantees interoperability between SDVoE devices. Again, using the SDVoE model, we can see that the API is able to manage exactly how the data packet needs to behave at each layer. So, when that packet is received by any other SDVoE component, it's an absolute certainty that everything will work exactly how it's supposed to. The SDVoE endpoints are responsible for sending video and audio streams across the network. The transmitters provide the streams, the network switch manages those streams, and the receivers turn those data streams back into the original content for the display. The first job of the controller is to allow the user to send the correct stream to the correct receiver. Once this is identified, the controller steps back and the streams will continue to be sent. Even if the controller fails, the system will continue to operate, but if the user wants to send a different stream to the receiver or change how a receiver needs to behave, the controller would need to be back in play.
It's important that the manufacturer utilises just the right amount of the API data which makes control simple. The API is highly complex in its raw form, and it can make any SDVoE endpoint do anything possible in SDVoE world. And while SDVoE features like multi-view compositing and gen-locking should be available, the manufacturer's software will only offer the features which the hardware is able to deliver to the display. A good example here is the multi-view application. The SDVoE API can allow for any type of multi-view compositing with any resolution, but it's down to the manufacturer to determine which multi-view compositing options are offered to the user, which falls within the bandwidth limitations. The control software is all about translating between high-level user commands and low-level SDVoE housekeeping, as well as building a targeted user experience from a wealth of possible controls. SDVoE controllers can be controlled by third-party control systems in the same way hardware devices can. For any given control system, an SDVoE driver is created, and from there, integration is easy. Many manufacturers of SDVoE equipment already provide drivers for popular controllers, but make sure well in advance. Discuss this with your manufacturer before specifying your system, because you don't want to be caught at the last minute realizing that you need a new driver for your chosen control system. It's important that you budget this well into your project well ahead of time if what you need doesn't already exist. Finally, remember that SDVoE is fully interoperable. So, an SDVoE control driver should be manufacturer agnostic. In other words, my touch panel driver for SDVoE will work with any mix of different manufacturers' SDVoE endpoints in your system. And it's this ultimate flexibility which makes SDVoE the matrix transformed.